Your MCP server needs to generate LLM responses, but you want full control over which model handles the request and how. You'll see exactly how to implement a custom sampling handler that processes conversation history, respects server preferences, and returns tailored responses, all while keeping the integration clean and maintainable. The pattern uses FastMCP's built-in types to handle roles, system prompts, and even multimodal content like images or audio.
From FastMCP import client. From FastMCP client sampling import sampling message, sampling params, request context. Async def basic sampling handler. Messages, list sampling message. Params, sampling params. Context, request context. SDR. Hash extract message content. Conversation equals. For message in messages. Content equals message content text if hassetter message content text else SDR message content. Conversation append f message role content. Hash use the system prompt if provided. System prompt equals params. System prompt or you are a helpful assistant. Hash here, you would integrate with your preferred LLM service. Hash this is just a placeholder response. Return F response based on conversation. Join conversation. Client equals client. My MCP server, pi. Sampling handler equals basic sampling handler.
This implements the callback handler pattern for language model sampling integration. The design treats LLM completion as an asynchronous service contract, where the client provides a handler function that conforms to a specific interface, but remains decoupled from the transport layer. What distinguishes this approach is the clean separation between message processing logic and the underlying communication protocol. The pattern works by establishing a standardized interface contract through the sampling handler signature, while allowing complete flexibility in the implementation. The framework handles message serialization, transport, and request context management, while your handler focuses purely on transforming input messages into a response. This creates a declarative boundary where the framework manages infrastructure concerns and your code handles domain logic. This matters because it enables seamless integration with any LLM service while maintaining clean architectural boundaries. The pattern solves the common problem of tightly coupled LLM integrations by providing a stable interface that can adapt to different providers without changing client code. It's particularly valuable when you need to support multiple LLM backends or when your sampling logic requires custom preprocessing of conversation history. Let's break it down. From FastMCP import client. From FastMCP client sampling import sampling message, sampling params, request context. These imports establish the FastMCP client foundation. Client handles server connections and message routing, while sampling message, sampling params, and request context define the structured interface for AI sampling operations, ensuring type safety and consistent request handling. This is the standard pattern for building AI-callable tools with FastMCP. Async def basic sampling handler. Messages, list sampling message. Params, sampling params. This defines the core sampling handler, an async function that processes AI model requests. It receives the conversation history as messages and generation parameters as params, enabling custom response logic, while FastMCP manages the protocol and connection handling. The async signature ensures non-blocking execution during model inference. Hash use the system prompt if provided. System prompt equals params. System prompt or you are a helpful assistant. This implements fallback logic for the system prompt. It uses params. System prompt, if provided, otherwise defaults to you are a helpful assistant ensuring the LLM always receives a system instruction. This pattern prevents undefined behavior when no custom prompt is specified.
Hash here, you would integrate with your preferred LLM service. Hash this is just a placeholder response. Return F response based on conversation. Join conversation.
This placeholder demonstrates where you'd integrate with an LLM service like OpenAI or Anthropic. The current implementation just formats the conversation history into a simple response, showing the expected return structure without actual AI processing. In production, you'd replace this with your model's API call.
Client equals client. My MCP server, Pi.
This instantiates the FastMCP client, connecting to the server defined in my MCP server, Pi. The client handles all communication between your sampling handler and the MCP server, routing requests and managing the protocol. This is the central entry point for integrating your custom logic with the MCP system. FastMCP sampling pattern. The sampling handler bridges AI models and client logic, transforming raw messages into structured responses while maintaining protocol neutrality. The handler must return a string, not a complex object, as the protocol expects plain text responses. This pattern enables seamless integration with any LLM backend while keeping the transport layer clean.
The handler that speaks to all models says nothing of its own.